Hi guys, I want to show you what we're doing in the classroom for this Kepler's Laws lab. We're doing a part one of this about Kepler's first law in the classroom, and I'd like you guys to try this from home because I do want you to have the experience of drawing some ellipses. This is kind of maybe some familiar material because we did this in earth science way back in the day. So anyway, so what you're going to need to do is you're going to need to go to my CBA. Go down to class documents. Actually, it's up here now. Class documents. Go to labs, and you're going to see a couple things. One of them is called Kepler's First Law Continued, and then there's Kepler's First Law, the PDF file. Open up the PDF file, and you're going to want to print this out because you're going to be writing a whole bunch of math here. So print this thing out, and you're going to be essentially writing down your answers right in this section right in here. Okay. Now let me actually go to my screen so I can show you what's going on. You're going to need some supplies, so let me go through the supplies list, which is on the first page, by the way. So let's go to here. Okay, so if you look at the top, it tells you to get some things. So thumbtacks, pencil, string, piece of cardboard, paper. Okay, so basic stuff I would hope that you have in your house, and if you don't, let me know. Okay, so I have also you probably are going to need a ruler. I'm using toothpicks rather than thumbtacks, and if you do have toothpicks, they actually work better. They're more accurate just because they're thinner than a thumbtack is. So toothpicks will work too. Some string, and you're going to probably want to cut like at least a, I don't know, 3 foot long piece of string or something like that. Okay, nothing fancy, yarn, whatever. A shoelace. You're not going to want to use a shoelace because you're going to cut this. So use something for this purpose. Okay, so I'm going to open up this lab and we'll just go through what you guys are going to be doing on this third page here. Okay, so it says, what separation between foci should you use for each ellipse? And it would be really worthwhile to read through this beginning section because there's a few equations in here that are really, really necessary. Okay, for example, if you look down here, E equals F over 2A. That's the equation for eccentricity. F is the distance between foci, and 2A is essentially this major axis all the way across. A is from here to the middle, and from there to there. Okay, so what you're going to need to do in order to figure out the separation between foci, you need to solve for F in that equation. So if I rearrange it, F equals 2AE. Okay, so this is, I'm going to do this for ellipse number 1 and number 2. I'm going to do the same thing for number 2 over there. Okay, so if you do the math, it tells you what A and E are down the bottom of this page. I know it's kind of out of order here, but there's E, 0.2, and A is 6 centimeters for ellipse number 1 and 11 centimeters for ellipse number 2. So I'm going to plug those numbers into my equation. F equals 2 times 6 centimeters for this ellipse times 0.2. Okay, you just do a little bit of math. You're going to do the same thing for ellipse number 2. Okay, now that's kind of handy. That's necessary to do both of those. You need to have the distance between the foci so you know where to put these pins. Okay, now the second question, again, you're going to do 2 different math setups, one for ellipse number 1, one for ellipse number 2. And this one comes from the string length. Okay, so the string length equation is right here, and it says S equals string equals 2A times 1 plus E. Okay, so I'm going to plug in some numbers. 2 times A, which remember is 6 centimeters, times 1 plus E, which is, I'll just shorten that 1.2, right? 0.2 plus 1 is 1.2. Okay, now do the math, figure out what your string length is. That's necessary because you need to know how big of a string you're going to use for this ellipse. So you're going to do that for number 1, and you're going to do it for number 2. And if you skip down through here, it'll tell you to draw them. And then there's a question here. And then there's this part, question number 5 and number 6. Now, you'll notice, if you actually look through this carefully, ellipse number 3 and ellipse number 4 are going to be math setups here. Number 3 is the same as number 1. So you don't need to do that twice. Okay, so I'll just put that there. Same as number 1, and again here, same as number 1. Okay, but you are going to have to do a little bit of math for number 4. Now, let's talk about actually drawing these things. Okay, I'm going to let you figure out the math, but I want to talk about drawing these things. First thing you want to do is take your paper, find the center of your paper. Okay, both this way and this way. Find the exact center, measure it, find it. You're going to want to draw a line right down the middle of your paper. I'm not doing this perfectly, but draw a line down the middle. Okay, find the exact center of this thing, put a dot there, and just write C. That's the center. Okay, now from that center, we have our focal distance. If you do the math here, I'll just do this one because it'll make more sense that way. You get 2.4 centimeters between the pins. Okay, so what I want to do, I'm just going to zoom in on this so you can see this a little bit closer. Okay, what you're going to want to do is make sure that your pins are located exactly 2.4 centimeters apart from the center of your paper. Now 2.4, half of that is 1.2, so I'm putting that at 1.2. There's a dot there, okay, and then over here, there's another dot, okay? So I'm going to put my pins right into those two places. I'm just going to stick it right through the paper, right into the cardboard, and you want to make sure that they're not going to move, okay? You really poke them right in there, like that, okay? And then you need to cut your string to the correct length. Now here's a little bit of a tricky part. Obviously you calculated how big of a string you need. Zoom back out again. But you want that string to be exactly that length when you tie a knot in it. Okay, so the best way to do this, I found, was to use a piece of tape. So just get some tape. And rather than trying to tie the knot right at the end there, put some tape on the end of this. And then just stick it on like this. You can kind of see what I'm doing, hopefully. I'm sticking the other end like this. They're right at the end of my other string. And then I'm just going to wrap my tape around a few times so it doesn't come loose. And so what I'm going to get is a string exactly the correct length, like that. Okay? And then you're going to put your string around your two pins. I made this string way too big. You're going to want to pull your string way out like this, okay, until the end. Let me get my smaller loop so you can see. Okay, so you have your string like that. You pull your pencil out like this, and you drag it around, making sure that it's tight the whole time. Okay, and then you drag it all the way. I'm not doing a very good job. Okay, but you get the idea. I broke my string in the process. Make sure your tape's on there good. Anyway, you guys get the idea. You're dragging this all the way around. And that will be ellipse number 1, so make sure you label each ellipse. Okay, so that's what you're doing for all of those ellipses, and then answering the questions that are there. Okay, there's a couple questions that are there. And then on that last page, which you also had to print, which was a separate file, you have this work to do. All right, so on the last page, this is the work that you have to do to figure out how far off you were in your drawings. Now, what I did was I edited my video a little bit, and I'll show you what it should look like. Okay, I fixed my string and redrew that. So take a look at this. What you want to do is you get a ruler and measure some actual distances here. So your distance between, I'm just doing ellipse number 1 for you. So you want to measure your distance between foci, okay, and write that down right on your paper. Okay, and you can pull your pins out if you want to, just measure from the hole to the next hole. Okay, be as precise as possible. And then what you want to do is you want to measure the length of the major axis. The length of the major axis is from here all the way to the other side. Okay, so you want to measure that. And that's going to really tell you how accurate you were. Obviously, I think your pins are going to be right on, but this is the number that's going to probably be a little bit off when you draw. So measure that as close as you can and fill that into the appropriate space here, length of major axis. The eccentricity can be calculated using this equation, right? Distance between foci divided by length of major axis, and that's going to be your number. that number and this number are probably not going to be the same. They should be really close to each other, but they might not be the exact same number. And so to calculate percent error of this, you're going to use this equation. Experimental value is the calculated eccentricity. Accepted value is the actual eccentricity. And then you have the accepted value on the bottom, and you multiply by 100. That'll give you your percent error. Okay? And then what I want you to do for all of them, and then tell me, what are your sources of error? Why are you off? How far off are you? Explain why you have error. Okay? And really, I think you guys can figure out why you probably have error. It really comes down to your string and your drawing and all that stuff. But try to be specific with that in your explanation. Okay? And that's pretty much it. If you guys have any questions about this, let me know. I'd like you to send me pictures of your results. That way I can grade that. And that's it. Hope you guys are doing okay. And I'll give you a happy Thanksgiving early. Okay? Have a great break.